Hi, my name is Emiliano. I'm going to talk about the Evidence 2, that is for the class Fundamentals of Behavior and Applications of Materials. And this project is about the stress strain characteristics of rubber bands. Well, this project it was meant to be to experimentally determine the stress strain behavior of rubber bands under progressive loading. The objective was to construct stress strain diagrams and analyze the elastic properties of natural rubber. In order to perform this experiment, we attached a scale that showed us of how many kilograms we were actually doing when we pulled the rubber band, as you can see in the video on the left, and we used a board to actually see how many centimeters that rubber band was stretching. Well, in this slide, we can see the first iteration of the first rubber band. We can see the stress strain curve on the left. It has a characteristic that is hyperelastic, and this is the shape of a natural band. It stretches really easy at low loads and then it stiffens significantly as it approaches fracture. We ran two elongations on this band. Both reach a maximum strain of around like 5, with a fracture stress of approximately 18,000 to 19,000 pascals at 12 kilograms of load. The R value squared is 0.908, and that confirms a strong correlation in the stress strain trend. And the band had an initial length of 90 millimeters, and the cross sectional area is 6.45 square millimeters. Well, for our second band, we can see that we had a very similar hyperelastic behavior with some key differences. This band is smaller and thinner with an initial length of 75 millimeters and a cross sectional area of only 2.7 square millimeters. It fractured at 7 kilograms, significantly less than band 1, which is directly explained because it has a smaller cross-section area. However, I noticed that the fracture stress reached approximately 18,000 pascals, and that's very similar to band 1. And this confirms that both bands are made of the same material, and the difference in load capacity is purely geometric, not because of the material. And we can see that we have an R square of 0.99, and this shows that it has a stronger linear correlation under this band. Well, in conclusion, both rubber bands show the elastic behavior of a natural rubber. They stretch a lot with little force at first, and they got much more stiff before they broke. This is very different from metals like steel, because that one have a clear elastic zone, the yield point, and then a plastic deformation before fracture. Rubber simply stretches and then snaps. No, there's no permanent deformation. Both bands broke around 18,000 pascals, which tells us that fracture depends on the material, not the size or the shape of the band. Finally, we did a double band experiment. It stretched less but broke at the same stress. This was expected because the material is the same and it has the same result.